Hi, in this video we are going to continue talking about related rates. We're assuming that you already know about them and know how to do some basic problems. We're just going to take it to next level. Some of these will have more than two quantities. So we have this problem. X is going to equal to this, and then we have a rate for dy over dt, dz over dt. We're trying to find dx over dt. So we're going to do exactly the same thing. We differentiate x, that's going to be dx over dt. We differentiate 2y squared, which is going to be 4y dy over dt. And we differentiate 5z cubed, which is going to be 15z squared dz over dt. And what we're going to do after that, we're going to substitute all the values because we have everything that we need here. So then dx over dt is going to be 4 times y, that's 2. dy over dt is -1 minus 15 times z squared, which is 1, times dz over dt, which is 2, and all that is going to give us -38. We don't have units here, it's units per unit of time. Example 2, we have this formula here. So this is a product, and when we do this problem we're going to have to use the product rule. So dp over dt is going to be, we differentiate r, that's dr over dt, multiplied by q cubed, then plus, we keep r and take the derivative of q cubed, which is going to give us 3q squared dq over dt. We have everything we need for this, and we're going to substitute everything. So dp over dt is going to be dr over dt is -2, q cubed is going to be -2 cubed, which is -8, plus r, that's 2, plus 3, times 3 times q squared is going to be 4, and times dq over dt, which is -3, and all that is going to give us -56. By the way, I want to remind you that a negative sign indicates that the quantity will be decreasing. Alright, of course it's going to deal with word problems, so let's talk about that. So we have a conical container that's leaking oil at the rate of 2 cubic inches per minute. So this rate here indicates the change of volume. So it's dv over dt equals, since it's leaking, it's losing the losing oil, and it's going to be -2. Okay. Now we know the cone is 20 inches tall and the diameter is 8 inches. So what we're going to do is we're going to draw a cross section because we need to tie some variables together. So we know it's 20 and it's 8 in the diameter, which means this distance here is going to be 4. So if I call this h and I call this r, then I can set up a proportion to connect h and r together. So we can say that h divided by r is going to equal 20 over 4. And from there, which variable we're going to need, it depends on the problem. We're trying to find the rate of change of h, which means we need to eliminate r from our formula, which means we're going to solve r in terms of h. So that's what we're getting. Now we're going to set up the volume for a cone. The volume for a cone is 1/3 pi r squared h. But we do need to replace that because, please note, we have too many variables here. So what we're going to do is we're going to substitute r with h over 5. So then v equals pi over 3 times h over 5 squared times h. And all this will become pi over 3 times h cubed over 25, and I can simplify that as pi over 75 times h cubed. This is our final expression. Now we can differentiate that. So what we're going to do, we're going to write dv over dt is pi over 75, that's a constant. We're differentiating h with respect to t, so it's going to be 3h squared dh over dt. And we need to substitute the quantities that we know. So we know dv over dt is -2. This is obviously a constant. 3 times h squared. H is given us as 4. Remember, we're dealing with 4 when it's the height is 4 inches. So it's going to be times 4 squared times dh over dt is what we're trying to find. So all we need to do now is solve this. It's going to be negative 2 equals, if we simplify all that, this is going to be, this is going to give me 48, right? So 48 pi over 25 dh over dt. And our final answer that we are going to, hold on, this is 75. This is 75 here. So this will simplify, I'm sorry about that, this will simplify to negative 2 equals 48 divided by 3 is going to be 16 pi over 25 dh over dt. And now we can say that dh over dt is going to equal, once everything is simplified, is negative 25 over 8 pi. Since this is negative, it indicates that the quantity is decreasing, and the units will be, and it's important, it's the change of height, so it's going to be inches per minute. Okay. A 5-foot boy is walking away from a street light at the rate of 4 feet per second. The height of the light is 12 feet. Let's draw a picture. So we have a light that's 12 feet. We have a boy who's 5. And we have the light from the street light is going to create a shadow. Okay, so what we're going to do here is we're going to figure out all the quantities. So what do we know? We know how fast the boy is walking. So that's how fast his distance away from the light is changing. We call this x. Let's call this distance s. So what we know is that dx over dt is 4 feet. It's positive 4 because he's walking away, the distance is increasing. And we're trying to find ds over dt, how fast the shadow is lengthening. So here's what we're going to do. We need to set up a proportion from the large triangle x plus s over 12 equals 5 over s. I'm sorry, s over 5. It's going to be s over 5. So we cross multiply, and that's going to be 5x plus 5s equals 12s. That's going to give us 5x equals 7s. And we differentiate both sides with respect to t. So 5 dx over dt is going to equal 7 ds over dt. So please note that the variables are no longer present. So it does not depend on the value on the distance from the light. And we're trying to find ds over dt. So 5 times dx over dt is 4 equals 7 times ds over dt. And ds over dt is going to equal 20 over 7. This is going to be feet per second. So it's increasing. Okay. Next problem, an airplane flew over a control tower in an altitude of 3 kilometers. The airplane is flying at the speed of 400 kilometers per hour. How fast is the angle of elevation is changing when the plane is 5 kilometers away from the tower? Alright, so here's what we're going to do. First of all, let's draw a picture. So we have a tower. We're assuming we don't have to worry about the height of that. So 3 kilometers is here, right? This is our angle. Let's call it theta. I'm going to call this y, and I'm going to call this x. So what do we know? We know from the right triangle x squared plus 3 squared equals y squared. This is from this right triangle, which is going to give us x squared plus 9 equals y squared. And what we know is if I differentiate this, I want to talk about this really quick. The speed is 400 kilometers per hour. That's how fast it's changing horizontally. So that's dx over dt, which is going to be 400. So if I differentiate this, I'm going to get dy 2x dy over dt equals 2y d. I'm sorry, that's dx over dt. That's dy over dt. So then I can say that dy over dt is going to equal to x over y dx over dt. So that's something that I'm going to need. Now let's go ahead and set it up for the angle. So we know that sine of angle theta is opposite over hypotenuse, so it's 3 over y. And what I'm going to do is I'm going to differentiate that as well. So I know that cosine theta d theta over dt equals negative 3 over y squared dy over dt. We make substitution. Okay. So what I'm going to do is I am going to, well, first of all, we know that cosine theta is adjacent over hypotenuse, so I can replace that with x over y times d theta over dt equals negative 3 over y squared times dx over dt, which is, I'm sorry, dy over dt, which is x over y times dx over dt. So x over y and x over y are going to cancel, right? So remember, this quantity came from here. Okay, so the rate of change of the angle d theta over dt is negative 3 over y squared times dx over dt. All we need to do is substitute the values. When this distance is 5, we have this distance, so dy over dt equals negative 3 over 25 times 400, and that's going to equal to negative 48 degrees per hour. Okay. Next problem. The length of a rectangle is increasing at the rate of 2 inches per second and the width is decreasing. So let's have a triangle. Let's call it width, let's call it length. So we know that dw over dt, that's the width. The width is decreasing, so it's negative 3. The length is increasing at the rate of 2. So please note, increasing means positive, decreasing means negative. How fast is the area changing? We know the area is going to be LW. So dA over dt, which is what we're looking for, equals dl over dt, we're using the product rule, times w, plus L times dw over dt. Right? So we can now substitute the values. We have all of them. So dl over dt is 2, w is, the width is 4, plus L, the length, which is 8, and dw over dt is negative 3, right? So we make all the substitutions. Now we can do the math, and this is going to come out to be negative 16, so it's going to be squared inches per second. Okay. Two cars leave from the same location at the same time. One car is traveling eastbound, another car is traveling southbound. So this is a very common type of problem. So one car is traveling eastbound, that's 60 kilometers per hour. Let's call this x, let's call this y. So we know that dx over dt is 60, dy over dt is 80. And we want to know how fast the distance is changing in 2 hours. So first of all, we need to tie the variables together. What do we know? We know that x squared plus y squared equals L squared. There's some distance between them. Let's call it L. And what we have is, if we differentiate this, it's 2x dx over dt plus 2y dy over dt equals 2l dl over dt. I can get rid of all the 2's. Right, and now we need to do a little bit of math. So what happens, what are the distances when 2 hours passed? So the distance y will be, in 2 hours this car is going to travel 160. This car in 2 hours is going to travel 120 miles. So what's going to be this distance? This distance is going to be it's going to be, let's see, if we use the Pythagorean theorem here, it is going to be 6, 8, 10, this is going to be 200. So we substitute all these values. The only one that we don't have is this. We have everything else, right? So let's make substitutions so that we can find the answer. So 2x, that's 2 times 160, no, 2 times 120 plus 2 times 160. I'm doing this. I'm getting ahead of myself. Let me get rid of the 2's first of all, so we don't have to deal with them. We can divide the whole thing by 2. Now we can substitute this. So x is 120 times dx over dt, which is 60, plus y is 160 times dy over dt is 80, equals L, which is 200 times dl over dt. Okay, so what we're going to do now is you can add all these together, and then you divide by, hold on a second. Let's check the math here. So 120 times 60 plus 160 times 80, it's going to give me 160 times 120, okay? And we're going to divide it by 200. It's going to give us 100. Okay, so dl over dt equals 100 kilometers per hour. Alright, last problem here. The height of a cylinder is increasing at the rate of 3 yards per minute. The radius of its base is decreasing at the rate of 1 yard per minute. How fast is the volume changing? So what we're going to have here, we have a cylinder. So a cylinder. So the height, let's call it h, we know that's dh over dt, is increasing at the rate of 3, so positive 3. The radius of the base, let's call it r, and we know dr over dt is decreasing at the rate of 1 yard per minute. And we need to see how fast the volume is changing. So the volume of a cylinder is pi r squared h. We're going to use product rule. We need to differentiate this. So dv over dt equals, I'm going to take pi outside parentheses so it doesn't get in the way. So derivative of r squared, 2r dr over dt times h plus r squared, derivative of h is dh over dt. Okay, and we can substitute the values now because we have everything. So 2 times r, the radius is 5, times dr over dt, which is -1, times h, which is going to be, height is 10, plus radius squared, that's 25, right? And the dh over dt is 3. So let's see what we're getting here. That's going to be pi. Inside this is going to be negative, hold on, let me see, 2r, r is 5, okay, so it's 2, 10, so it's -100, right? -100 here, plus 75. It's going to give us -25 pi, and that's what it is, right? negative 25 pi, and the units are going to be cubic yards per minute. Okay, and so since it's negative, it shows us that the volume is going to be decreasing at that moment of time. Hope this helps.